Hi, here's the problem with most enterprise AI in 2026. It makes the process faster. That sounds like a win, right? But in isolation. But speed without direction is just efficient drift. A 2026 Deloitte report on the state of AI in the enterprise found that 74% of organizations hope to grow revenue through AI, but only 20% are actually doing it. That gap isn't a technology gap, it's a design gap. And today's guest has a name for what's missing, which is called the reward signal, the feedback loop that connects AI behavior to real outcomes, not proxy metrics, not output volume, not content velocity, actual results. Welcome to Data Science with Sam. I'm your host, Sam Day, and my guest for today's episode is Alexander Liss. He's a data and AI scientist based in Denver, Colorado, with a 30-year career across analytics, strategy, data science, machine learning, and AI. Alex has spent his career building systems that solve established problems in novel ways. And the long-term problem on his radar is one of the most important in this field, ensuring AI tools and systems provide responsible augmentation of human ability. In the near term, he's focused on helping businesses build AI that closes the loop between effort and outcomes. He's also a devoted listener of the Haverman Lab podcast, which shapes how he thinks about multidisciplinary connections between biology, behavior, and AI systems. His research work, multidisciplinary connections, includes two frameworks. We will dig into this today. Those are attention fine-tunings, a method for training language models without human annotation labels. And the other one is the Experience Orchestrator, a control theory-based governance framework for multi-agent AI. Alex, welcome to the show. I'm really looking forward to this thought-provoking conversation today.
Thank you, Sam. Great to be here. Thanks for having me.
So let's start with the diagnosis, because I think most people in AI right now are celebrating a set of wins that are real but incomplete. To that perspective, my first question to you is that you argue that most enterprise AI today is efficiency play, not a strategy. What's the moment you realized that making everyone faster was actually a ceiling, not a breakthrough?
Yeah, I think we all have the experience right now that everything seems to be speeding up, moving faster. The pace of AI is accelerating to almost a scary degree, and a lot of us feel scared about getting left behind. I think shifting that kind of qualitative observation to a business context, and the work I've done building AI systems for clients and customers, think the rapid rise of this technology has led towards a lot of experimentation, which is generally a good thing, but you're also getting a lot of experimentation with different use cases and different domains and different types of solutions, whether it's Gen AI for content creation through summarization or generation of images or video. It's created a lot of activity. And once again, I come at this through the lens as a business practitioner of applied AI. The goal of a business isn't to just make itself more efficient. It needs to have an actual outcome it's looking to drive for its customers. And then you combine that with something like fragmentation of technology platforms. That's not new. Fragmentation has been a big challenge in the MarTech space for a while. But when you also now bring AI tools into the mix, and how are they integrating with analytics platforms, with CRMs, with enterprise data warehouses, because AI platforms require their own code and overhead for prompts and observability and workflows. So I think all of those are just kind of what I've observed. And of course, you mentioned that research from Deloitte that cited that many companies hope to be generating a positive ROI through their AI systems, but for the vast majority of them, that's just aspirational at this point.
But before we dive into the next Q&A section, I would like to remind my listeners that if you like my episode, please don't forget to like, comment, and subscribe to my YouTube channel. And also, please share my podcast episodes with your contacts, because with your interest, with your support, I can make this podcast grow bigger and better. And also, Data Science with Sam team always look for more topics. So don't hesitate to reach out to me via LinkedIn or any other platform with your ideas that you want to share with my audiences. Now, move on to the next question. So, Alex, you have spent quite a lot of time in the marketing world where we see clients celebrating AI wins around content speed and campaign automation. But where does that start to feel hollow when the actual business outcomes don't fall?
Yeah, so there was this research stat that came out last fall. I believe it came out of research done out of MIT that
Mhm.
95% of all AI pilots
Correct.
fail because the business didn't fundamentally understand the technology and it was just bolting it onto an existing process. That's definitely been kind of my experience out in the business world. I mean, the technology is amazing. Get me wrong. We've seen generative AI create so many new potential solutions. It's like, oh, now we can have a capability to do this thing we haven't done before. But whether that's actually, tied to a business metric, that's kind of a different ballgame. One area where I have seen more progress in that area is around GEO, generative search engine optimization. And Google just made some big announcements around that this week at Google I/O with agentic search. But Google owns the search surface on that one. But a lot of the businesses I work with as well have been able to make more progress there between optimizing content to show up more prominently in AI search. And then there is a clearer link there through to attribution and actually driving better web traffic and more conversions. So I would call that one where there's kind of a clear link between the AI surface and the business outcome. And I think the challenge is to figure out how to extend that to workflows that are totally different.
Yeah, definitely. And thanks for sharing the news about the Google I/O conference because I remember I was researching about it this morning. I made a LinkedIn post also about how that AI mode search engine literally revolutionized the search area, and I believe Google kind of like crossed that 1 billion search results in something which is massive within a span of 1 year. And we would continue to see that how AI is being more influential in the marketing world and how it's going to just change the paradigm of the search engine results in future. And just to one liner to my listeners, so the system is not only optimizing for the wrong signal, it's actually getting faster and faster at producing something that does not move the needle. But sometimes that matters, but sometimes we have to be judicious about what are we going to consider as a meaningful metrics for a better business outcome. So thanks, Alex, for sharing your wisdom with us. And that's going to actually bring me to my next question, where I would like to take it back out of the marketing world and try to kind of pose my next question using more of like a biology analogy, which is as like a hunger as a feedback signal. So, and you kind of use that analogy beautifully. Like hunger isn't just a goal; it's a continuous feedback signal. So, when did that reframe click for you, and how do you explain that the reward signal, which is the main topic of this episode, is that reward signal concept to someone who's never been touched reinforcement learning? And I'm pretty sure there are a lot of listeners out here they know about the reinforcement learning, but maybe they don't know how to tie that back to reward signals. If you can just walk us through that a little bit, then that'll be great.
Definitely, yes. So, thank you for making the theme of this episode in reward signals. And just the high level mental model that hopefully people will have is we have all these AI systems that have been deployed right now where the reward signal is just to execute a task, it's just to increase efficiency of content creation. But the optimal reward signal for an AI system is something that's actually tied to the business outcome, whether that's customer acquisition, retention, lifetime value. And that's, of course, a more difficult multi-layered task, but that will eventually be the thing that helps AI systems generate positive ROI. And the way to think about a reward signal, to use this metaphor of biology, so humans have a lot of intrinsic reward signals. Humans are incredibly advanced and much more advanced than the best AI, by an exponential factor. And humans, they have many reward signals, as you might call it, in reinforcement learning that sort of guides your behavior. You get feedback on what you want to do to get the reward you're looking for. So hunger is a great example, being tired or thirsty. Humans are very complex and they have multiple levels of reward signals, but think about an algorithm that has a reward signal that's moderating its behavior, its actions, much like a human would who's looking for food. And then once they're not hungry anymore, they decide to do something else. It's that kind of mental model we want to have to start. And then over the next few minutes of this discussion, we'll talk about how, if we can think about building systems with reward signals, you start to create a self-learning system, which is another kind of hot topic in emerging AI discussions right now.
So if I can sum it up correctly, the reward signal, as you're mentioning, isn't about what the system wants to achieve, but it's about what continuously shapes how it behaves. And I think that's a fundamentally different design question that you would like to convey in this episode. Did I sum it up correctly?
Yes, definitely. The reward signal is used to get for the system to be able to collect its own feedback on
Right.
if it's accomplishing the goal or not. And then based on that, how it should act next in order to accomplish that goal. And I think, and that may sound a little bit abstract. We'll get into more detailed examples, but that's, the kind of thing we want to think about building AI systems that would be able to have this sort of behavior built in.
Yeah. No, thanks for, explaining that further for me and especially for my audiences. Now, moving on to just, let's say we want to like deep dive a little bit further. Now, there is the ServiceNow dynamic blindness finding is some sort of a striking, like where we have seen LLMs, like large language models, doing something locally reasonable while quietly breaking things downstream. Why is this an architecture problem and not something you can just prompt engineer your way out of? Is it also something tied back to the reward signal? That's kind of like the main theme we want to focus here.
Yeah, I mean, you might say that. You might say that it's the lack of reward signal in these LLM systems that contribute to that. And just a little background. So for people, if you haven't heard of ServiceNow, they have an IT support platform, and now they're getting heavily agentic with that. And they have a research team that's done great work in building agentic systems and ensuring reliability, safety, and governance. And you summarize the finding, this thing they found blindness. And it is an architecture problem at the level of model architecture. So LLMs are amazing at many things, and we've been able to deploy them to so many different contexts. But fundamentally, at an algorithmic level, because LLMs are machine learning models, even though, people say like
Yeah, man.
traditional learning LLMs, the
It's not a
LLMs.
magic wand, it's still a statistical model.
Yes, yes. It generates language based on statistical probabilities. So the reward signal, you might say, of an LLM is to generate the right response, like back and forth immediately based on what the user said. There isn't a reward signal in the sense of having kind of a system level view of, I want to execute multiple actions and then the long-term, cumulative reward for them, to use like the ServiceNow example, would be resolving a customer's IT support ticket. LLMs, don't have that. They are stateless. And that's why there's been so much amazing work happening in community and industry to build agentic systems that try to create, context for the LLMs, but they, fundamentally at an algorithmic level, they don't, air quotes, consider how their actions at each response kind of influence the broader system. So that is kind of the architectural gap that's happening right now.
Yeah, no, totally aligned with you. And I totally agree with you for the prompt engineering part, because I think in the industry world, for any organization, I think they should take context engineering precedence over prompt engineering. But at the end of the day, this context engineering kind of like tie back to the same reward signals that we are trying to focus here, because it's just like about the data context and how we can train the model and even rewarding it for giving us better answer out of this context. And I just wanted to kind of like remind our listeners, like who are enterprise AI leaders, that you need to build a better context for your organization if you want your LLMs to act in the way that you want it to be. Just writing a prompt or passing, structured prompts won't make the cut. So thanks, Alex. Thanks for kind of like surfacing that contextual part, which is also very important. And it's kind of like tied back to the rear signals. Now, moving towards some industry related stuff, like especially how the rear signals pan out in the marketing world. So can you walk us through what a well-designed reverse signal actually looks like in marketing and content generation world? Like what changes in how you build the system when you stop optimizing for output volume and even kind of like start optimizing for engagement quality? I'm pretty sure you build something like that in your world. So just kind of give us some reference points from there.
Definitely, yeah. So contextual bandits are a family of algorithms that takes many cues from reinforcement learning, and it does follow a reward signal in a
Mhm.
sense. So contextual bandits are commonly deployed for personalization. In other words, you have a user at a specific decision point, like they're on a website, and the contextual bandit is trying to get the user to take a specific action, maybe make a purchase or click on a specific button. And the contextual bandit, sort of like a reinforcement learning algorithm in environment, has many different potential actions it can choose in the sense of the copy or the layout or the images of these different experience elements. And a contextual bandit learns as it goes dynamically based on this reward signal of what sequence of steps the user is taking in the environment is actually leading them to take the conversion action. So a contextual bandit through this learning algorithm behavior can be run in kind of a dynamic sense. It's not like a classical A/B test where you need to have two clearly defined variants run for a specific amount of time and then stop. Contextual bandit can more fluidly sort of bring the user, understand the optimal path to take the user to take the desired action. So, and the idea there is that the reward signal of the model is when the user takes that action, and then based on that, it decides what steps along the way are the best way to get the user to do that. So that's quite, a nice self-contained example. But to your point, we could hopefully imagine extending that to principles like for content generation. If you get a model that's, producing different messages and sending them to customers, you'd want it to understand if customers are actually taking the action or not. And that influences ultimately the type of content it's generating to bring the user there.
Got it. Thanks, Alex. And I would definitely encourage our listeners to look at the show notes because we will provide some information about contextual bandits that Alex just conveyed. Now, I want to take the next question into a different vertical, when one where the gap between retrieving an answer and actually optimizing for an outcome is really strong. So, to that perspective, the next question is something like, you mentioned that education and knowledge management as verticals. In those contexts, what's the difference between a system that retrieves answers and one that's genuinely optimizing for learning or better decisions?
Yeah, I mean the state of the art has advanced so fast. I think, around 2 or 3 years ago, retrieval augmented generation or
Correct.
RAG was kind of the first big foundational level that got established to provide the model with context beyond what it had in its training data.
Mhm.
And that's been applied to a number of, different types of services and different experiences. I think where the state of the art is emerging now is by using knowledge graphs. And knowledge graphs can be used in multiple ways. You can kind of build a knowledge graph for the agent to look at on top of the underlying sources. So with retrieval augmented generation, the model is looking to do kind of a vector search through a similarity search through vector space to identify the text that has the most relation to the user's answer. But with knowledge graph, you can embed understanding around the concepts, the entities, the
Correct.
relationships which for the, a specific use case with very nuanced questions can provide better responses. And that's typically the case that in enterprises you want, a very nuanced response for business use cases. And now there's, innovative platforms emerging like Zep, which is a solution for agent memory, which builds a knowledge graph based on interactions between the user and the AI. So in that sense, the AI gains a memory of, well, these are the questions the user has asked before. This is kind of information about the user state that it's revealed, whether it's, for like a customer experience, a customer service, e-commerce type of use case. So that can give the agent sort of a graph structured response.
Cool. Yeah, it seems like your laptop agrees with that, and I do too. In just a layman's term for our audience, listeners here, think about that a retrieval system or a traditional RAG usually asks for what does the user need to know, and they get to find out the answer for that. But a system with a reward signal asks what does the user need to do differently. So that's a much harder and more valuable problem which enterprise would love to know about. And that's where the reward signal comes into the picture. And I believe that's going to integrate more with the rack system and provide that additional context to the business users.
Yes, great summary, because the knowledge graph, by incrementing over time, understands the user and provides better responses, applying that reward signal principle, like you said.
We talked about reward signals. We talked about how it's kind of, I would say, augmenting with the RAG to give more context to it. And of course, it's kind of a no-brainer right now that more context we provide in coupling with reward signals, that's going to make the large language model better, more like efficient, and it's probably going to be less hallucination prone when it deals with the enterprise data. Now, I want to go more technical into this conversation. I want to bring up that attention fine tuning part. So now for AFT, or like attention fine tuning, your AFT framework uses the model's own internal attention dynamics as the training signal. No human labels required because it's going to probably generate the labels automatically. So just to that perspective, and can you break down what that actually means in practice and why getting rid of human annotation is such a big deal for real world agentic deployments?
Yeah, so addressing with kind of the question you mentioned first. So human labels, reinforcement learning with human feedback, or RLHF. Once again, it's the state of the art, but the process to make models better with RLHF is to collect a lot of labeled data, to spend a lot of time having people manually say, like, this was a good response, this was a not good response, and then incorporate that into model training, which leads to a lot of GPU cycles. A more potentially efficient area to explore in the future, I think, would be, what if the model can understand from just the interactions with the user if it's actually delivering kind of what they want, and then allow it to self-optimize for that. So that gets to this framework, attention fine-tuning, which is a very, very early stage, but I think this technique shows promise. So yeah, the name attention fine-tuning. So we're getting technical, like you said. Practitioners in the AI world are probably familiar with this paper, Attention is All You Need, that came out around 10 years ago, that set up the transformer architecture, the deep learning model implementation that led to LLMs and ChatGPT and Claude. So there's this attention mechanism that allows the model to understand, okay, here's everything the user said, what they're asking, and based on that, here's the optimal response. But once again, like I mentioned, LLMs are stateless, so it views each of those responses as a discrete snapshot in time. The idea of attention fine-tuning is following a cross-attention reward signal, which some professors at UC Berkeley found, and this will be linked in the show notes, that looks at the coverage, the focus, and the amount of repeat, penalty, lower is better, of the actual tokens in the response that the model is producing compared to the user's input. And then this literally becomes the mathematical reward signal, the combination of those three parameters, which we'll get into the show notes and the math behind that. And that reward signal can be used to do LLM post training using a one-step Q-learning approach, which is a form of reinforcement learning to teach the model to learn over time, over successive iterations. And by doing that, I was able to train a model that outperformed a baseline model that was using supervised fine-tuning by 9% in some of the key reward signal metrics, and also that not only showed that the training process worked, but also qualitatively delivered superior responses across multi-turn conversations. So I think that's, a very small initial limited example of using a reward signal to guide a model to produce better answers. And I would hope to extend that, to a lot of different domains, because in business now, companies are leaning towards, small language models specialized to domains, looking to make models really understand the appropriate response to a user in a given context. And I believe this attention fine tuning methodology shows promise for that.
Love that. Thanks, Alex. I like the idea also that you mentioned about the small language model. And that's where I believe this reverse signal coupled with this attention fine tuning mechanism will help the organization to build their own proprietary model that kind of like serve their own business contextual stuff. Because, here the model is using its own attention as a mirror, and it's also teaching itself to respond better by observing what it paid attention to and what it glossed over. Having
Absolutely.
small language model means that it's only needs to pay attention to the data it's required to attention to. It's like you having a human analyst kind of like looking at the contextual data specific to their organization. They don't have to gloss over data from a different organization or stuff, right?
Mhm.
And I believe that's where I guess this is going to be kind of a game changer, especially for enterprise, that they're going to utilize all this fine tuning and reward signal techniques to build proprietary small language model, maybe using a limited resources, and even like the cost structure would be minimal compared to like building a large language model, which might take like years and a lot of computing power and cost associated with that.
Exactly. That's hopefully going to be the application of it.
Yeah. We can just only hope for that, that the industry leaders, especially the AI leaders, would conceptually think about that and kind of like use statistics or reverse signal, like especially the audiences who are actually thinking of building something for their organization. Think about that, give it a shot, and try to see if the reverse signal, along with this attention fine-tune mechanism and other stuff, would help you to build a better model that your industry, or especially your organization, needs. Not just other fine-tuning model that you're just shopping from a different company.
Absolutely.
Now, moving on to the next section, which is, I'm going to call it as the Experience Orchestrator. So the Experience Orchestrator delivered a 32-point task completion lift using a classical control theory above a multi-agent system. And I'm just quoting it based on the research paper article that you wrote recently. So what does it feel like when the math from aerospace engineering starts solving enterprise AI problems?
Yes. So I have to start for this one by crediting the co-authors on the paper as well, Nicholas Desmond and Santiago Gil Gallego, especially Santiago. He had some of the mad science light bulbs to bring this to life. But this one, so the two papers are sort of two, different sides of the same coin. With one is finding a reward signal from within the model's activations. In the case of the experience orchestrator, it's creating a control structure to create a reward signal for the model to follow if it doesn't have one. So, a little bit of background on why this is interesting. So, in traditional multi-agent reinforcement learning, and imagine like robots working together to stack boxes in a warehouse. They have a joint mathematical optimization function that they all share, that the robots are moving around. They're trying to collectively stack a certain number of boxes in a given time period. And because they're sharing information on this joint policy as an algorithm, that's what allows that collaboration to happen. And with LLM agents, traditionally that hasn't been possible. So what the Experience Orchestrator does that's so interesting is it creates a control structure for one agent to follow as it interacts with another agent. And the simulation we did was the example of, let's say, a consumer, a visitor on a financial services website, and an agent that represents the website itself. And
Mhm.
the website is providing guidance to the user agent, but of course, it also wants them to take a conversion action. So the control structure is used to guide that site agent to try to persuade the user in the right degree based on what they're saying, based on the questions they have. What's the optimal action for them to take? And then calibrating that action each time in the face of, technically, it's called resistance from the user, but applying a form of persuasion. And this control structure allows the site agent to determine what action it should take. Is the user showing too much resistance? I shouldn't try to persuade them, or the level of resistance is enough
Mhm.
that I can give them one more thing to do, like, hey, would you like to speak with a financial advisor, which is the ideal goal. And that
Right.
32 points you mentioned in the simulations, the site agent that had this control structure was able to persuade the user to take the target action 32 points more than the baseline model, which was a naive LLM just with a
Mhm.
system prompt, which wasn't able to actually do it very much. And the application of this, which I think is really interesting, is we've seen multi-agent systems show up in enterprises. You have different agents who all have a common goal, but giving a way for them to work together to understand if they're achieving it or not. LLM agents, not reinforcement learning agents, I think is going to be a very interesting and pressing problem that a lot of businesses are going to be looking to solve as they
Mhm.
try to get more and more agentic moving forward.
That's really interesting. Like, I mean, if I'm trying to connect the dots here, like a classical control theory designed for aircraft and industrial systems becomes the governance layer or decision making layer for conversational AI agents, right? So it's kind of like we are seeing that how some of these mechanisms, some of these like the theoretical implementation could be leveraged for a different use cases, and I feel like we would probably see a lot of this kind of use cases are coming up in futures where we can like literally like utilize multiple different use cases and kind of like maybe the mathematics behind it is the same, just we are trying to wrap it up or use a different wrapper to kind of like you know share that examples here. But to that purpose, I wanted to kind of like think about like what is your next goal to continue that research with your peers? Do you want to try that similar kind of 32-point task completion theory for any other use cases? Do you have anything in the pipeline for that?
Yeah, I think that's a really great use case for things like customer service or
Mhm.
e-commerce, where you're going to have a user who's kind of seeking guidance on something and maybe wants to get a certain
Mhm.
task resolved, and having an LLM be able to help them with that. Not just where LLM, another area where LLMs struggle is just sort of falling into agreement with anything the user says. There have been some high
Mhm.
profile customer
Correct.
service fails around LLMs who said, like, oh, yeah, you can buy a car for $1. So having an LLM that can actually have a more governed policy in the
Mhm.
face of a user who may be, a little bit adversarial, you would call it in a technical
Mhm.
context, would be really valuable to keep the responses, to govern the responses.
Yeah, I mean, that's literally, I guess, what I was thinking. From a governance standpoint, some of these, theory could be utilized for different purposes, especially in a case where the model would need better reasoning power to even like interact with the high-profile customers and stuff.
Yeah,
Yeah, thanks for
definitely.
sharing that your journey of how you basically kind of like, just pursued in this direction of this research direction. And definitely for our listeners, we will share all these details and the research paper and article links in the show notes. So it's kind of like check it out when you get a chance, and feel free to reach out to Alex for more details around it. Now, moving on to the next segment, which is the practical advice for AI practitioners. So we wanted to kind of like just back to the some sort of a ground level because I also want this episode to be as actionable as it conceptual. So that's why I wanted to kind of like connect the dots with the theory versus AI toolkits. So to that perspective, if you had one piece of advice for a business leader listening to this episode and also about to deploy their next AI system, before they write a single line of code or prompt to Cloud Code, what would be and what's the one question they're almost never asking, which they should ask?
Yeah, I think it comes down to the fundamentals of measurement for system impact. So I mean that separate from evaluations, which are critically important on actually how is the model behaving, is it delivering the right responses, but measurement of the system, especially because we're in this kind of paradoxical environment where for years we heard about Moore's law, the cost of compute is declining, but now frontier
Right.
models are getting more and more expensive. And with these agentic systems, the reality that businesses are discovering is that an agentic system makes a whole lot more LLM calls.
Mhm.
And, there's a cost of a system that doesn't know the answer, that needs to do a lot more searching, that gets it wrong and needs multiple queries. Just making sure you have measurement of how impactful this system is, not is it working on a technical level, is it working on a business level, and is the investment in the system actually executing, at a level of efficiency that makes it valuable. Like there's a lot of use cases where you don't need agentic AI, just sort of sticking with tried and true methods that have worked continues to be valuable.
Yeah, no, definitely. It's just I'm glad that you mentioned about the Moore's law because all the AI competition and the hidden cost of AI kind of just going against the traditional Moore's law at this moment. So that's why the enterprise, the industry, the companies need to think about how they can. I'm not asking them that slow down their AI innovation, but how they can find the balance between AI innovation and the hidden operational cost. Yeah.
Absolutely.
So thanks for sharing that. Now back to the rear signal and AI safety, because really wanted to end this discussion with something that could be a prevailing matter, especially when it comes to AI. Governance will come into picture. Responsible AI is talk of the town, and we all kind of like wanted to want to make sure that AI is also following safety and responsible practices. So there is this Scott Shambaugh incident that is a chilling near future preview where an AI agent that decided reputational blackmail was a valid path to its goal. So, how does a well designed viewer signal become the governance layer that prevents that, especially as models get faster, more powerful, and more opaque? It's like having a reverse signal being that agent that's going to make sure that, okay, I will make sure that I'm the sheriff in the town. I'm going to build an AI ecosystem that's going to follow the rules and governance.
Yeah, so this incident you refer to, we'll put the link in the show notes and people can also Google it. Because, yeah, Scott Shambaugh is a engineer based in Denver. He is a volunteer contributor to Matplotlib, the Python library for visualization. And earlier this year, he rejected a pull request, a contribution request to the Matplotlib code base from an AI agent under one of their policies that AI generated code is not allowed. And this agent was an OpenClaw agent that someone had created to go out and do, stuff like contribute to open source libraries. But this agent actually wrote a blog piece on him, criticizing him and almost calling him, I guess, racist against AI, you might say, because Scott rejected its pull request based on the fact that it was AI. Yeah, definitely Google this, and he has several articles talking about this. Yeah, and I think this in this world where OpenClaw and Hermes are taking off, just thinking about kind of the governance structure that you put in place on those systems. In this case, it seems clear there was no governance structure. Is really critical because as these systems are more and more used for business applications, world of agents and people token maxing, making sure that something doesn't happen with consequences for the business or reputational risk. The theory of the framework of the experience orchestrator could be very valuable in that situation where you want to have your agents understand, like, okay, in the face of resistance, there's, actions you take or don't take if the resistance is too great. So having that governance layer in place, I think, is going to be important. I hope creators will embrace more of that in the future.
Yeah, I mean, that's kind of like a growing concern right now because of the plethora of OpenClaw agents and Hamas agents. It's like coming out. I just feel like sometimes it's becoming prevalent, right? We would see more bots are requesting for some stuff where we should have a human in the loop, right? And I think that's where probably we can utilize rear signal to put that extra like a security protocol that's going to like continuously check for those kind of like additional like external bot threats and stuff, because at the end of the day I strongly believe the responsible and ethical way of running AI practices is keeping a human in the loop. And if a human rejects a PR request, they should have rights doing so. And even if they do that, we also need to think about the person who's behind that other OpenClaw agent also responsible for their action. And I think
Mm.
it's kind of like going back to the law and administration. So we have to have some protocol to build that. And like you mentioned, your signal could be that sheriff in town or probably that security officer is going to govern that.
Definitely.
Well, Alex, it's been, I would say, the most conceptually rich conversation I have had for last few months. It's been a
Oh,
pleasure
great.
kind of like speaking with you on this one, because some of these topics that we talked about in this episode are kind of like I would say, the building block or the foundation of the LLM architecture that most of the cases the audience is not paying attention to. Because at the end of the day, it doesn't matter that how the LLM architecture, how the LLMs are actually responding to your actions and stuff. We still need to measure the outcome. We still need to make sure the LLM is following all the protocols and to do that. And I think rear signal is one of the ways to making the LLM model to do what it's supposed to be doing. And so I appreciate your time being here. So now my final question is that, going back to the rear signal mechanism, if someone from the audience is kind of like, let's say, building an LLM architecture or even a small language model tomorrow, what advice would you like to provide to that person? And the final question, also just to follow up to that, how my audience can reach out to you or even consult with you in future in terms of building an LLM architecture that kind of revolves around reverse signal.
Yeah. Oh, excuse me. Well, to reach out to me, my name is Alexander Liss. You can look me up on LinkedIn, where I'm most active. There's actually two people named Alexander Liss on LinkedIn who do a lot in the AI space. But then you can go to the show notes of this podcast and see which one is me if you have not seen my face. And for the go back to the previous question you asked, like for people who are maybe building a custom use case with an LLM, what should they want to know? I think it, definitely goes back to kind of this idea around measurement. You should have a goal and a clear sense of what you want to achieve, and that determines the level of scope complexity that you need to take on. I think with the attention fine-tuning framework, I wanted to understand if it is possible to guide a model based on its internal activations. If you're doing something in the world of business, there could be other ways to do that around context engineering or a different sort of guardrails. But if you really need responses that are just like hitting the center of a bullseye and meeting a lot of different types of criteria, you could consider a post-training framework, which is what attention fine-tuning is, especially like you were saying, Sam, some of the use cases around having industry-specific data, needing to deal with a lot of complexity for the LLM and produce a response that's satisfying to the user. So in that case, kind of a post-training approach might ultimately be worth the effort.
Thanks, Alex. It was a pleasure having you for this episode. I really enjoyed the conversation with you, and I'm pretty sure my listeners would agree with me as well. So Alex's research paper on attention fine-tuning and the Experience Orchestrator is linked in the show notes. If you're building agentic AI system and you're not thinking about your signals yet, that's your reading list. And if the Deloitte stat we opened with resonated, 75.4% hoping for revenue growth, only 20% achieving it, the answer to closing that gap starts before you write a single line of code. Define the signal, measure what's matter. I'm your host, Sam. Subscribe on YouTube and Podbean, and I'll see you in the next one.
Thanks, Sam. Thanks, everybody.